We're in. We're rolling. Okay. Unit 6, lesson 1, you guys, we're going to be talking about the slope of a line for this lesson. We've already talked about slope in Unit 5 a little bit. This is really not going to be much new, just more of a review. This lesson is very easy and very simple. We're going to fly through. So just a little reminder, slope. What is slope? What's the fraction I said a lot in the videos to describe slope? Atiena? Rise over run. Yep. So slope is rise over run. What we do up, down, divided by what we do left to right. Okay? That's a very simple way of saying it. When we have a graph in front of us, we take two dots, we jump between the two dots, rise over run, done. But sometimes I'm going to ask you to find the slope without actually giving you the graph. I just give you points. Okay? So another way to find slope is the following formula. Y with a little subscript of 2, a little 2 on the bottom, and I'll explain that once we get to an example, minus y1 divided by x2 minus x1. That is the infamous slope formula. You're going to see that a lot over the next 3 years. Yes? You're doing a bit of slope in science. You're in like a graphing unit. Perfect. We're doubling up on graphing, learning lots. Perfect. Okay, so we are going to kind of use these two ideas today. Rise over run if we're given the graph, and then that formula if we're not given the graph, essentially. So I'm just going to do a little recap of how to find the slope when we have two graphs in front of us. So this one on the left here, you always have to find 2 points. And I talked in the videos about finding perfect points, okay? A perfect point is a point where the line crosses an intersection of the grid marks perfectly. So that's why I chose this guy right here, because it crosses these grid marks perfectly. And then the other one I gave you was the one up here. And all we do is jump. How much do we have to rise and how much do we have to run? So 1, 2, 3, 4, 5, 6, 7. I had to rise 7. So that's a positive 7. And then 1, 2, 3, 4, 5, 6, 7, 8. I had to run to the right 8. Don't we turn the front light off? Will that help? Okay. Great. Now, that's one way to find our slope of 7 over 8. If you're a little bit crazy and you want to start there, you certainly can. If you want to start there and travel to the other point, what you would have to do is you'd have to go down 1, 2, 3, 4, 5, 6, 7. So down 7 would mean that your rise is now negative 7. And then to the left, 1, 2, 3, 4, 5, 6, 7, 8. To the left is negative 8. So the slope you would get if you did it that way, the crazy way, is negative 7 over negative 8. But what happens? This answer is the same because two negatives cancel out. So those two guys are actually the same thing. And I never, ever, 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 ever want you to leave your answer like that. That's bad math etiquette. You should cancel out those negatives for your final answer. Okay? All right. Next one. Here's my first point. I have to travel down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I went down 12, so there's my negative 12. And to the right, 1, 2, 3, 4, 5, 6, 7. To the right is positive 7. So in this case, my slope would be my rise, which happens to be negative 12, over my run, which is positive 7. The negative there wouldn't cancel out. We leave it. And there's a little recap on how to find slope. Not so bad, right? We can all hop. All right. There are 4 types of slopes. Okay, we're going to review those right now. Positive slope. So for example, if I gave you a slope of like 2 over 5, that's a positive slope because it's not negative. 2 over 5. Now, a positive slope is always going to look the same. They are always going to travel in that direction, going up. Like if we were at the base of that hill, we would have to travel up, a positive incline. Or if you're on the treadmill, we put our incline up, we're walking uphill, okay? The other slope, for example, is a negative slope. So all of a sudden I just throw a negative in front. Negative slopes are similar to each other in that they will always angle downward. So again, I think I even did this in a video. I drew a little stick man. If you were at the top of that hill, you'd have to run down that hill, negative. Now, the next two, students always confuse these two. Okay, so take really good notes here. A zero slope. If I ever give you a zero slope, it's going to look something like this, for example, 0/4, which means if 0 is on top, my rise is 0. I don't go up or down at all. I stay there and then I move to the right 4. So a slope that has a 0 on top is always going to look like a flat line because I have no rise. I'm not rising at all. I'm staying flat. Okay. If ever you calculate a slope and you get it to be like 0/4, you should really just write 0. 0 divided by 4 is just 0. Okay. Now, undefined slope is the opposite when the 0 is on the bottom, when there's no run. If you tried to punch 4 divided by 0 into your calculator, what would happen? Error. You cannot divide by 0. Impossible. Okay? So we call this an undefined slope when 0's on the bottom because there's no run. We don't move left or right. All we do is rise. So it's a complete vertical line. And if you think of that in terms of a treadmill can never go upright like that. That would be completely impossible, or we call it undefined. Okay? Students always mix these up. 0 on top is possible. It's just a flat line. 0 on the bottom, that's trouble. Okay? All right. Next page, we're already halfway done. We're going to practice drawing slopes, okay? And I gave you a few different slopes, a few different situations here. So it says trace a line for which the starting point is the origin. Where's my origin? The center. There. There's my origin, there's my starting point. Then it says draw the given slope. So we're going to draw a slope of 7/5. So rise over run. I'm going to rise 7 and then run 5. They're both positive, so it's up and it's to the right. So if I go up 7, 1, 2, 3, 4, 5, 6, 7, and then to the right 5, I end up right there. You join your two dots. Put an arrow on the end because that shows we could go on forever. Like we could do another 7/5, 7/5 until we're blue in the face, but we're going to stop. That was an easy one. They're both positive, nothing really to think too hard about. This next one, there's a little curveball in it, something we've got to think about. Again, we're starting at the origin. Now, you'll notice when I wrote that slope out, I put the negative in the middle, right? This is negative and then 3/8. When you do the slope though, you guys, you have to assign that negative to someone. Is the 3 going to be negative or is the 8 going to be negative? And I'm going to show you both scenarios. So scenario number 1, I'm going to make the 3 the negative and the 8 the positive. So I'm just kind of inching that negative up so it belongs to someone. So if that's the case, I'm going to go down 3 and to the right 8. My rise is negative, so I go down 3, and then my apologies, if I go 8 to the right, I'm just 1 off the grid. I didn't make it quite wide enough. So that's down 3 and to the right 8. There's option 1. But again, if you're a little crazy and you want to give the 8 the negative, you're totally allowed to do that. In this case, your 3 is positive, so you'd go up 3, but your run is negative, so we're running to the left. So again, if I start at my starting point, I'm going to now go up 3, but then to the left 8, and we'll see that they're all connected in a nice straight line. I drew the same line, but one was on the left half, one was on the right half. It doesn't matter what you do for me, just choose one. Okay? Cool. Last one. Again, we start at the origin. What's my slope? Yeah. -5/1? Is that what you think? Yeah? No? Huh? What do we think? Is that over 0 or is that over 1? Any number. Don't overthink this. You have learned this since like elementary school. Any number is actually always over 1. It's not over 0. Okay? So there, it's over 1. So that means we're going to go, whoops, down 5 over 1. So the 5 is negative, so my rise is negative. I go down and then I go to the right 1. And there we go. Okay? There is always someone, always, who sees that -5 and they don't stop and think for a second. They just think, oh, my rise is -5. What they do is they go, okay, I'm going to go down 5, and they put a line there and they go like that. That green line, what's the slope of that green line? It's completely vertical. Treadmill, is that possible? No, that's an undefined slope. I didn't give you an undefined slope. I gave you a -5. So that should be a trigger. Something's wrong. Okay, so we always have to remember that a -5 is actually over 1. And we have to just go one little unit to the right. And there's your slope of -5. Okay, now, next question. In the textbook or on the exam, I might give you a question like this that says, determine the slope of the line that passes through the points A and D. So I don't draw the line for you. I just say we have 2 points. If we connect those 2 points, we'd have a line. I want to know what's the slope of that line. You have 2 options, whatever floats your boat here. On the left, you draw it. You actually draw those 2 points out, you connect the dots and you do your hopping. If you like drawing and you're a visual person, this is for you, okay? So what I would do here for option 1, trace the line, and I would plot these 2 points. So there's my first point. A, I'm going to plot that on -5, -3. You guys remember how to plot points? You go to the X is -5. But then you go to where Y is -3, and that is the point A. Then you plot the point 2, 1, that's D. So you go to X is 2, Y is 1, there's the point D. And just like that, we've drawn that line. All you have to do then to determine the slope is do your hops. 1, 2, 3, 4, up 4, 1, 2, 3, 4, 5, 6, 7, to the right 7, and there's your slope. Easy peasy lemon squeezy. But if you're not someone who likes to draw, you don't want to pull out graph paper, barf, that sounds awful. Option 2 is you use the formula. This is the formula I gave you on the front page. Okay, and we plug the points in. So I'm just going to write them out here. The points that I gave you were -5, -3, and the other point I gave you was 2, 1. So whenever I give you points, the first value is X and the second value is Y. Right? The first point I gave you, therefore, we could label as X1, Y1. The second point I gave you, therefore, we could label as X2, Y2. So now all I do is plug them into that formula. So the formula says I start with Y2, which is 1, subtract y1, which is -3. So be careful, you now have two negatives up top there because of the subtraction, and then 3 was already negative. On the bottom, you take your x2, x from your second point, which is 2, and you subtract x from your first point, which is also a -5. So in both scenarios, we have a double negative, which we know is a positive. So on top, 1 plus 3 is 4. On the bottom, 2 plus 5 is 7. And voila, we get the same answer. Who would rather just do the formula? Okay, both split. All good. Last question. Couldn't be easier. Save the easiest for last. I want you to think about something for a second. Rise over run. When we rise, what axis are we mimicking? Which axis goes up, down? Y. When we run, which axis goes left, right? X. So really, we could say that rise over run is like Y over X. Okay? So if I say here, when X increases by 2, Y increases by 5, if I want you to write that as a slope, you put the Y movement on top and the X movement on the bottom. So Y increases by 5 and X increases by 2. That would be the slope that describes that, 5 over 2. 5 goes up, or Y goes up 5, X goes up 2. That would be like this. Up 5, 1, 2, 3, 4, 5, to the right 2. Up 5, up 2. When X decreases by 3, Y increases by 6. So again, put your Y movement on top. So Y increases by 6, that would be a positive 6, but then it says X decreases by 3, goes down, decreases, negative. You always reduce your fractions. There's your slope, -2. When Y increases by 4, X goes down or becomes negative or becomes less, so -3. And finally, when Y goes down 5, so I now have a -5, X doesn't move. What does that mean? It's 0. You can't leave your slope like that. You have to finish this off. No! When 0's on the bottom, we have trouble. When we have trouble, that probably means our answer is impossible. That's an undefined slope and 0's on the bottom. Cool? Done. So your homework's written on the bottom there. You're probably going to need graph paper, so I'm going to come around and give you a few pages, okay?